right, we are slowly working our way through this unit, and we're talking a lot about slope and lines and things that describe lines and stuff like that. So in 4.5, we're going to keep going. The I can statement for today is I can find the slope between 2 points using the slope formula. Now, a formula is going to make things a lot easier to find. That's the case with many times when we have a formula. It'll make it easier to find the answers. So let's take a look at the warm-up here. It says slope equals m. Remember, m's the special letter that we use to represent slope. It's the change in y over the change in x. Remember, this is the second quantity, difference in the y's. That's the vertical change over the horizontal change, because x runs in the horizontal direction. And then in the last unit we talked about a quick little way to find it on a graph, and that would be the rise over the run. So remember, slope we use an m, it's the change in y over the change in x, or graphically we can just find it quickly by finding the rise over the run. Quick reminder what slope is, got a couple blanks to fill in here. So remember, slope is a fraction. It's a fraction that describes how steep the line is. It tells us two things: how steep it is, okay, and it tells us in which direction it slants. Direction, okay. Now, it says on this one, label each slope as positive, negative, or zero, or no slope. So let's take a look at this one. Remember, we always kind of check things from left to right. This one goes down from left to right. So the slope on this one would be negative. So again, I just write m, and everybody knows that means slope. So the slope on that one would be negative. If we take a look at the next one, this one is perfectly flat. So remember how we tell here the difference between zero and no slope? On this one, there is something for us to land on. So there is a number that represents how steep this is. It happens to be 0. And then this one right here, if we were heli skiing or something like that, getting dropped off, there is nothing for us to land on. If there's nothing for us to land on, then there is no slope. Okay, so on this one, we would say that there is no slope. Okay. And then on this one right here, remember this one goes up from left to right. So if it goes up from left to right, then that tells us that the slope would be positive. Okay. Now on D, this is a kind of an interesting problem here, and I just put this on here to get you used to the type of thing that we're going to see in the formulas a lot of times. So it says find the difference between the 2 points in the example below, and then it says note the subscripts. So I'm going to talk about subscripts. If you haven't seen these before, here's what this means. This is an x-axis. We've got this number line running horizontally. So this is x1. Literally all that means, okay, is we're going to say x1. That's how we say it. Let me put a little bit of space in between there. x1, that's how we say it, and it literally just means it's the first x. So x2, that's how we say that, x2, and it literally just means it's the second x. That's all it means. So if we're going to find the difference, now if you keep this in mind, it's going to be really helpful in the long run. If we want to find the difference between the two of these, we normally take the one on the right and we subtract the one on the left. So the one on the right is 5, and then we're going to subtract the one on the left, so that's going to be -2. Now notice there are two negatives next to each other, so remember that's going to be a negative times a negative is a positive, so that's going to be 5 plus 2, so we end up with 7 altogether. Okay, so there's the answer right there. And I want you to take note of the subscripts. The subscripts, this would have been x2 minus x1. Okay, that's what we would have done if we wrote it down in subscripts. So we take the second x, we subtract the first x. It happens to be that the first one happens to have a negative in front of it, and a negative times a negative is positive, so we get 5 plus 2 is 7. Now, let's just verify that by, we've got a graph, let's go ahead and count. How far is it, or what's the difference between the two of these? Well, let's count. This would be 1, 2, 3, 4, 5, 6, 7. 7 spaces in between them. Now, I usually have somebody say, well, hey, why can't you just do it backwards? So let's check and see what would happen if we did do it backwards. Let's say we did x1 minus x2. So x1, that's the first x, that would be -2. We'll write a minus. And then x2, that's the second x, that's a 5. So we put those together and we get, this would be -7. Well, if we're talking about the difference, which a lot of times, especially when we're talking about a graph, we're talking about the distance between the two of those, we want to know how far it is between the two of those. It's 7 units between them. It's not -7 units, okay? So just kind of by convention, we always do that x2 minus the x1. So just kind of keep that in mind as we go through, and you'll see why we use those subscripts in just a few minutes. So it's really easy to find the slope if we're given a graph. We've been doing that for a while. We've been drawing triangles and things like that. Last time we talked about how we can give a name rise over run, but there are times where we will only be given 2 points. Now, if you're only given 2 points, you could graph the points, but you may not have a piece of graph paper, and graphing can be a little bit imprecise. As we saw, we have to kind of pick convenient points, and if we don't have a piece of graph paper or we count wrong or something like that, we're going to get the wrong answer. So in cases like this, if we're only given 2 points, it would be really nice if we had a formula. Now, you've dealt with formulas before. Formulas just work if we're finding the area of a circle or the area of a trapezoid or something like that. Rather than figure each one of those out from scratch every single time, what we can do is we can plug the numbers into a formula, it spits out the answer, and we're all done. We don't have to bog ourselves down with thinking about, gosh, how would I figure this out from scratch every single time? So here's what we're going to do on example number 1. We're going to figure out what that formula would be. So we've got the point 1, 1 and the point 5, 3. Now, it says use subscripts to label the points, so I'm going to go ahead and do that right now. I'm going to label this one as x1 and y1. That literally just means the first x and the first y, so it's the first xy pair, and x2, y2, so that's the second xy pair. All right, now let's go ahead and graph these. So this would be 1, 1, so we're right there. And then the other one would be 5, 3, so 5, 3 is right here. All right, and I'm going to blow this up so we've got a little bit more room as we're doing this. So we want to find the slope between the two of these, so we want it to look like that. So let's see what we've got here. Let's see, this point was 1, 1. That is x1, y1. And this point right here is 5, 3. That is x2, y2. Now, this might seem like I'm just way overkill, but this will make sense why we're doing this in just a second. Okay, so let's go ahead and draw our triangle like we normally do. So I'm going to go ahead and draw this over here. That's our horizontal line. That's like our base, and this is our height for our triangle. Okay, and I'm going to go ahead and label this one right here. This is x1. Okay, so that coordinate 1, that's the x coordinate for the first one. And this one right here, this is a 5, that is x2. Okay, and I'm even going to make that look like it's a 5. In fact, maybe I'll change that on the notes so it looks a little bit better. So we've got that 5 right there. Okay, and then in the y direction, we've got this point right here. So this is going to be y1. And this point over here, this is going to be y2. Okay, now we want to figure out how far it is from here to here. So just like we did up above, we're going to do x2 minus x1. So x2 is the 5 minus x1. There's the x coordinate for that one right there. It's a 1. So we end up with a 4. And then this one right here, this would be, so sticking with the same idea, if we did the right one minus the left one, okay, we're going to do the bigger one minus the smaller one if you want to think of it that way. This one would be y2 minus y1. So y2, that's going to be the second y. How far are we up here? So let's follow that over there. So that would be a 3. And then y1, follow this over here, that y coordinate is 1, so we're going to subtract 1. So we end up with a 2. So this is the difference in the y's, and this is the difference in the x's. So that means the slope on this one is going to be, let's see, if this is the rise, if you want to think of it that way, that's going to be 2. And if this is the run, if you want to think of it that way, that's going to be 4. So we end up with 1/2. Okay? So there's our answer, and again, I'm going to label this as rise, so we're straight on that one, and we're going to label this one as run, so we're straight on that one. Now, that's the answer. Just for the heck of it, I'm going to come back here and I'm going to change colors. Let's just say from scratch, we did it the way we've been doing it in the past. Let's just count. 1, 2, 3, 4. So the run would be 4. go up 2, so the rise would be 2. So if slope is rise over run, that would be 2 on the top, the rise is 2, and the run is 4, so we end up with 1/2. We end up with that either way. Now, the thing about this particular problem is we had nice points, we had a piece of graph paper, we were all set to go. So this one wasn't too bad, and it builds right on the stuff that we already know how to do. What would be nice is if we could figure out what is a formula where I don't have to graph this every single time. So here's what we did. Notice that the rise, that's the difference in the y's, and we've talked about the difference in the y's, or the vertical change before. That goes on the top. So we're going to write down a formula for this difference in the y's. We're going to do y2 minus y1 on the top, and then the difference in the x's, just like that problem that we did up above and the one we did right here, that's going to tell us what the run is, so that's going to be x2 minus x1. So this is the formula that we're going to use. So I'm going to put a little asterisk by it right here. Now I do want to point out something that you've got to be really careful with this formula. Okay, we're not going to be graphing these all the time, so we won't have this as kind of like a double check. You've got to remember that that minus is part of the formula. It is not the sign of a number in there. So remember up here when we were doing this problem how that minus was kind of part of the formula. We were finding the difference. We're going to subtract the two of these. When we do that, that is a minus, that's part of the problem. It's not the sign of the number. If the sign of the number is negative, then we do negative times a negative and it turns into a plus. So we've got to make sure that we keep that in mind. So on this one it says determine the slope of the line that passes through -2, 4 and 1, -2 using the slope formula, and then check your answer by graphing it and see if it turns out the way you expect. So the graph is just here to check. So here's what we're going to do. Let's write down the formula. The formula sitting up above. You're going to say this over and over again. So we have known slope as rise over run. Now we've got another formula for it if we've got 2 points. So think of it this way. Slope is y2 minus y1 over x2 minus x1. So please make sure you've got that formula memorized. It is not going to go away. You're going to use that in every math class from now until you're done taking math. So remember, x1, y1 just represents the first xy pair. x2, y2 represents the second xy pair. So we're going to plug these things into the formula, and please watch and be very careful with this. So here's the way I like to do this. Let's go find y2. y2 happens to be -2, so it's y2 minus. Please write down the minus and then go figure out what y1 is. y1 is right here, it's a 4. Okay, so there's the problem that we're going to have to figure out on the top. Then on the bottom it's going to be x2, so let's find out what x2 is. So that's going to be a 1, and then minus, go ahead and write down the minus, and then go find x1. x1 happens to be -2 on this one. So now that we've got those written down, now we can find the answer. So this is going to be -2 minus 4, that's going to be a -6. This is going to be 1 minus -2, so this is going to be 1 plus 2, and we end up with a 3 right there. And remember, this is a slope fraction, so we always want to reduce that fraction. In this particular case, we get -2 over 1, or the slope on this one is -2. Now, before we graph this and check and see whether or not this is what we expect, let's think about this. Remember, slope is a fraction that represents how steep a line is and in which direction it slants. So the fraction here is 2 over 1. Okay, 2 is a pretty big number, so we're expecting a fairly big slope, and it's negative. So we're expecting this to be fairly steep, okay, and down from left to right. So let's see what happens if we graph these points. So the first one is -2, 4, so that means we're going to go back 2 and up 4. So there's x1, y1. And x2, y2 is 1, -2, so 1, -2, we're right here, so that is x2, y2, all right? And the line that would connect those would go like this. Okay, now notice that it does go down from left to right, and it's pretty steep, so that looks good. That kind of confirms our answer here. If you wanted to double check another way and actually go through, since we've already got this graphed, let's draw one of our slope triangles, and let's count this off. This would be 1, 2, 3, 4, 5, 6, so that would be a rise of -6. and this would be a run of, remember we're counting spaces, so 1, 2, 3, so that would be a run of 3. So we do -6, the rise, over 3, the run, and we end up with -2. So that confirms that we got the right answer, so we're in good shape there. Okay, let's flip the page over and let's remind ourselves of what we've covered so far about slope. Remember, slope is a fraction that represents how steep a line is and in which direction it slants. We use the letter m to represent slope. We're always going to do that from now on. If we have a graph, then we think of it as rise over run. So if we've already got a graph, if they're already graphed, if we've got a line on a graph or something like that, if we have a graph, let's just think rise over run and we'll be counting things off. It's much easier that way. However, if you just have 2 points, then it's a heck of a lot easier to take the formula y2 minus y1 over x2 minus x1. So please make sure you have all of this stuff memorized. You've got to be able to recall that at the drop of a hat. And remember, the thing that people mess up the most is they forget and they think that the x's have to go on the top. Remember, it's the change in the y's, or it's the vertical change over the horizontal change. So make sure you get that flipped. That's why we've been doing the up-down part and putting it on the top, always saying it's the second one on the top and the first one, or the horizontal change, on the bottom. So make sure you keep that in mind. Okay, let's take a look at number 3. It says find the slope of the line using the given information and then match each slope with the letter of the line that has that slope. So we've got to be careful because sometimes they'll give it to us in the wrong order, and they might say something that seems a little bit weird, or maybe not using the same vocabulary that we've used on other problems. So it says the change in y is 6 and the change in x is 8. So the change in y, that's another way of saying the rise, whether we went up or down. So that's going to be the rise right here. And the change in x, that's going to be the run. So we would put the rise on the top, the run on the bottom, and we'd end up with 3/4. Notice that it's positive. Okay, so positive, it's going to go up from left to right. Left to right. Okay, and not very steep. Not very steep. Okay, so let's take a look through here and let's see if we can find one that goes up from left to right. Okay, that one goes up from left to right, so that's in the running. That one goes down to from left to right, so that's definitely not it. And this one goes up from left to right, and it's not very steep. So I'm going to say it's this one right here. We're going to say that this one is C. Okay, so there's our answer for our slope, and there's our answer for which graph it is. So we're going to match it up with C. I'm going to make that look just a little bit better. 3/4, and we'll put a plus right there. Okay, let's take a look at the next one. This one uses the words that we're familiar with, rise and run. So we're going to put -8 on the top and -2 on the bottom. That's going to be a 4. It's positive, so that's going to go up from left to right, and it's a pretty big number. It's much bigger than this one right here. So the slope is 4, and so this goes up from left to right here on C. That one goes down. The only other one it could possibly be is A. So we're going to mark A. We're going to match it up there. And then this one, take a look here. It's got an asterisk by it. So on this problem, the run is 2 and the rise is -1. Notice that they gave it to us in the opposite order. So please don't put 2 over -1. The rise goes on the top, so it's rise over run. So it's -1 on the top and then a 2 on the bottom. That is our fraction right there. Okay, so this one's going to go down from left to right, and it's not going to be very steep because it's a fairly small fraction, and so that's this one right here. It kind of confirms what we would think it would be. Okay, you do have some problems like that, and then I'd like to take a look at these right here, because this is really showing whether or not you know what you're doing on these problems. It says determine the slope of the line passing through each pair of points using the slope formula. Just using the slope formula. Now I guarantee you're going to have problems like this on the test, so please make sure you know the slope formula, know how to find the slope between 2 points just from that formula. It's going to be really to your advantage to have that memorized. So I'm going to write it off to the side here. So again, we're going to write M. If we have 2 points, we're going to do y2 minus y1, and then we're going to do x2 minus x1 on the bottom. So x2 minus x1 on the bottom. Now, please make sure you do these in the right order. So we're going to write down x1 and y1 and x2 and y2 right here. So we're going to do 6 minus 4. Now, one thing that can be helpful, I have had some people say that they like writing the minus on the problem to begin with, so I'm going to go ahead and write a minus here, and we're going to find out what y2 is. y2 is 6, y1 is 4, and x2 is 4, and x1 is 3. So this is the order we do these in. And let me just point this out. We don't want to mix up the order. If we do y2 minus y1, so if I match these up this way, I need to make sure that I'm matching those up that way. I can't switch this around and do 3 minus 4 if I wanted to. It doesn't work that way. So whatever order you do the y's, you've got to do the x's. So if we do 6 minus 4, we need to do 4 minus 3. So we're going to do y2 minus y1, and then we're going to put that over x2 minus x1. Now you'll notice on this particular problem, 6 minus 4 is 2. 4 minus 3 is 1, so we get an answer of 2. We're done. It's literally that quick. Take a second to stop and think about what this would look like. This would be fairly steep in a positive direction, so this would go up from left to right, so it might look something about like that. Now, these both have asterisks by them, and let me tell you why. Notice that they've got a bunch of negatives in there. If there are negatives, when we plug negatives into formulas, people tend to make mistakes, so please make sure you're careful with this. So again, I'm going to mark this one as x1, y1. This is x2, y2, and I'm going to write down the formula, and it might not be a bad idea just to write this down several times. So y2 minus y1, x2 minus x1. This is a little bit overkill, but I think it's a really good thing to do when you start out doing this, just to make sure you've got this memorized. So I'm going to write down the minus in the middle of the top and bottom so that I don't forget that, and it's going to be y2. Let's go find that. So that's a 3. Minus, we've already got that there, and y1 is a 3. Okay, so we're going to put that there. And then we've got x2 is negative 4, minus, that's part of the formula, and then we've got the negative 6. Okay, 3 minus 3 is 0. Oops, let me make that look like a 0. And then this would be a plus 6. Okay, minus 6 would be a plus 6. So put a big plus right there. So that's going to be 2. And remember what happens when we have 0 over 2? It's totally okay to have 0 on the top. It's not okay to have 0 on the bottom. We've got 0 divided by 2. If you needed to double check, throw it in your calculator. It will tell you that the answer on this one is 0. Okay, so the answer on that one is 0. All right, let's take a look at this last one. Again, the slope is y2 minus y1 over x2 minus x1. I'm not going to do that all the time, but I'm going to do it enough that you hear me say it and you make sure you get it memorized. So I'm going to put the minus in the middle of the top and bottom. I'm going to take the second y, so that's going to be a 10, minus the first y, so that's going to be a 2. So notice that I matched them up this way. So if I did that, then I need to do x2, which is the negative 5, and then we're going to have minus the minus 5. So this is going to be, let's see, that's an 8, and then minus a minus 5, that would be a plus 5, so that would be a 0 in the denominator. Now remember what that means. If you've got 8 divided by 0, go ahead and type it in your calculator. It will tell you there's a problem with that. So we could say two things. We could say no slope. In other words, there's no number that represents how steep that is. There's nothing for us to land on if we drop it off on that mountain slope. Or we could say that it is undefined. Undefined. Either one of those is totally okay. I would take either one of those answers. Okay? All right. This does take a while to get used to. Make sure you practice. There's some little details that you want to make sure that you're aware of. And you might make a mistake here or there, but make sure you get some help, get it cleared up. We've got plenty of time before the test, but make sure you're working hard and asking questions. All right, good luck.